Okay, hello. This is section 6.1 functions and system of the equation in two variables. So, introduction for the many quantity in everyday life depend on the more than one variable. For example, you're looking for the area, but you need to require the width and length for the rectangle. And heat index is the function of the temperature and humidity. And wind chill is determined by the calculating the temperature and the wind speed. And grade points average is computed using the grades and also the credit hours for the class. So functions into variables. In arithmetic, operation of addition, subtraction, multiplication, and divisions are computed by functions of two inputs. So in addition, function of f can be represented symbolically by f of x and y, and same as x plus y, and then z equal to fxy. So z is going to be the functions, and then the x and y will be the independent variables, and the z is value going to be the dependent variable followed by the x and y. So in the first problems, I'm looking for the value when x is a 2 and y is a 3 in the functions of 2x minus 3y. So when you plug it in, I got 4 minus 9, which becomes negative 5. And then I have a v functions, which is using the radius of the 3, height of the 2, which is plugged into the 1/3. Pi of r is a 3 square, and then h is a 2. So when you simplify that, the 3 squares are 9 and 2 times, and 3 goes 9 3 times. It becomes 6 pi. Okay, and system of the equation in two variables. So linear equation in two variables can be written in the form of ax plus by equal to k, which is a, b, and k are the constants. So this is we call the standard form, which is a and p cannot both are the 0. A pair of the equation is called the system of the linear equation. Because they involve solving more than one linear equation at once. And then solution of the system of the equation consists of the x value and y value that satisfy the both equations simultaneously. And the set of the solutions is called the solution set. So when you have a linear system of the linear equation, we get the one solution. So because solution will be the intersection, these are the solution, okay? So this examples for the one solution case, but you only see the one line, but the other lines are actually the overlapped. So which means the two lines are exactly the same line. So this case we call the consistent, but that's a dependent equations. And then this equation is the no intersection, which is we call the no solutions. And then but still, but we need to say inconsistent for the no solution case. All right, so let's look it up the another problem. So example 2, the graph each system of the equation and find any solution. Identify the system as a consistent or inconsistent. If the system is consistent, and you also need to state that the equations are the dependent or independent. Okay, so the first one, so I want to actually label the equation. So I want to solving the equation by graphing. So I'm graphing the first equation. So this is actually you can use x in a set. This is 1 and 0, because y is a 0, minus n, which is 0 and negative 1. So you got 1, 0, and 0, negative 1. And then this is actually the line of the equations. Okay, so this is equation 1. Now, equation 2, I think I want to use another color, which is I'm graphing negative x, y, plus y equal to 1. Oh, I want to use a slope for this one. So when I solve for y, I got x plus 1, which is slope is 1, which is 1 over 1. And then minus 7 is 0 and 1. So from the oh, it's a negative 1. Sorry about that. Yeah, was something, yeah, kind of not right. Okay, so sorry about this. So this is actually equal to negative 1. So yeah, this I need to write the right ones, okay? So which means so for y is a -1. So it's going to be -1. So 0, -1. So from here. And then going one up, one right, one up, one right. Actually, you get the same line as the first one. So number 1 and number 2 are the same line. So this is the case of the consistent. So when it's a consistent, we have to say it's a dependent or independent, but this consistent means always as a case of the dependent because you only see the one line. Alright, next equations. I have number 1 and number 2. So equation 1, I got 2x minus 3y equal to 1. And then this time, I think I want to solve for y. So subtract 2x both sides. Negative 3y equal to negative 2x plus 1. And divide by negative 3. And then I'm getting it at 2/3 x minus 1/3. So this time, I'm gonna use a slope, but minus step doesn't look good. So I want to find another point. But if I say x is a -1, plug in -1, -2 minus 1 is -3/3 is a -1. So I think I got another point. So I want to use the 1 and -1, and then use the slope of the going from here 1, 2, 1, 2, 3, which is I got another point is right here. 1, 2, 1, 2, 3 is right here. And then which is a down 2, left to 3. Okay, so that's actually the line for the first equation. Okay, and then equation 2, I got x plus 2y equal to 4. And so for y, subtract x both sides. I got 2y equal to negative x plus 4 and divide by 2. And then I get y equal to negative half of x plus 2. So slope is -1/2, which is down 1, right 2. I intercept as 0 and 2. So from 0, 2, I go down 1, right 2. Oh, already got intersection, right? So if you connected it, yeah, that's the line. So this one has a one solution because this is the solution, which is going to be 2 and 1. So you got 2 and 1 is the solution. So this is a one solution case. So which is a consistent, but this is actually we call the independent case because you have a two independent lines. Now at C, equation 1 and equation 2. So the equation 1, I have 3x minus y equal to 4. And so for y, subtract 3x both sides. I got the negative y equal to negative 3x plus 4. And divide by negative 1, I got y equal to 3x minus 4. So slope is a 3/1. And y intercept is 0 and -4. So from 0, -4, I need to go 1, 2, 3, 1 right. 1, 2, 3, and 1 right. So this is a line. Okay, and then the equation 2, which is -3x plus y equal to 1, and so for y at 3x plus side, y equal to 3x plus 1, so slope is 3/1, and then y intercept is from the 0 and 1. So from the 0, 1, you go 1, 2, 3, 1 right, which means down 3 and 1 left. Okay. So this is a line, which means it looks like a parallel to me. So parallel means this equation, this graph of the equations never meet. So this is we call the inconsistent. So if this is inconsistent, we don't have to worry about dependent or independent, but this is actually the dependent case. Alrighty, let's look at the next page. Now, in this time, okay, we got more problems, so let's see how we can handle this one, okay? So, example 3. In 2010, revenue of the McDonald's and Burger King totaled 26.4 billion, and McDonald's revenue exceeded Burger King revenue by 21.8 billion. By the system of the equation whose solution gives the individual revenue each company in $billion. So I want to say, yeah, we need to actually define that. X is the gross sale at the McDonald's, and then let y is the gross sale at Burger King. So if you're adding it together, total is 26.4 billion. And then McDonald actually the exceeding for 21.8, which is the growth from the McDonald's to the growth for the Burger King, and the difference will be the 21.8 billion. That's the systems you can get. Now we're gonna solve this. So x plus y equal to 26.4, and then x minus y equal to 21.8 to solve. Alright, now you can use the graphing, but doesn't look nice this time. So I want to use a substitution this time, okay? So equation 1 and equation 2. So pull out the equation 1, and then I want to solve for y. So x plus y equal to 26.4, and subtract x both sides. I got y equal to x 26.4 minus x. And then I'm going to plug into the y right here. So I got x minus y is 26.4 minus x, which equal to 21.8 minus 26.4 plus x equal to 21.8, and 2x minus 26.4 equal to 21.8. Add a 26.4 both sides, and then I get 2x equal to the 48.2. And then when you divide by 2, and then I get x equal to 24.1 billion, which is the McDonald's. And then, so for y is, you need to plug it in, this x is in this equation. So y equal to 26.4, subtract 24.1, and then I get 2.3 billion. So which means x represented as a McDonald's revenue is 24.1 billion, and then the Burger King and revenue is 2.3 billion. All right, see, is your system consistent or inconsistent? This time is actually the consistent because you have a solution. Because the system has one solution. Okay, all right, let's look at the next page. Now I'm going to talk about substitution method, but I already show you how to do the substitution method. Okay, so with the substitution method, to use a method of the substitution to solve the system of the equation in two variables, perform the following. So step 1, choose a variable in one of the two equations and solve the equation for that variable. So we need to isolate the one of the variable. And step 2, substitute the result from the step 1 into the other equation and solve for the remaining variable. And then use the value of the variable from the step 2 to determine the value of the other variable. To do this, you may want to use the equation you found in step 1. And to check your answers, substitute the value of each variable into the given equation, and this value should satisfy both of the equation. And then for the elimination is another way to solve the system of the equation symbolically. This method is based on the property that equals added to equals are equal. That is, if the a equal to b, c equal to d, and a plus c equal to b plus d. So the goal of this method is to obtain an equation from which one of the two variables has been eliminated. All right, so solve the system of the symbolically. So let's use this for the, I'm using a substitution. So equation 1, equation 2. So pull out the equation 2 because x term is only the x by itself. So I want to x plus 5y equal to 13. I'm going to solve for x. So solve for x means subtract the 5y both sides. Your x equal to 13 minus 5y. And then I'm going to plug it in this one into the first equation in x place. Okay, so 3 times of x, which is 13 minus y. minus 2y equal to 5. I got 39 minus 15y minus 2y equal to 5. And then 39 minus 17y equal to 5. And then subtract 39 both sides. I got negative 17y, which is a negative 34. And then divide by negative 17. And I have it equal to the 2. So now we need to find the y, find the x, plug it in the y in here. So x is now 13 minus 5 times 2, which is 13 minus 10, which is a 3. And then solutions are always x and y order pair. So x is a 3, y is a 2. That will be the solution. Of course, when you plug it in, it must satisfy the both of the equation. Okay, next page. In this equation, it's better to use the substitutions, but you can use elimination too. But I'm gonna use using a substitution. So equation 1 and equation 2. So equation 2, because I'm looking for the always any variable that one has a coefficient, which is a y. So I'm gonna solve for y. Which means I need to subtract the x squared both sides. I got y equal to 5 minus 3x squared. Then I'm going to plug it in 5 minus 3x squared into the y in the first equation. So 5x plus 3 times of 5 minus 3x squared equal to 1. And then simplify 15 minus 9x squared equal to 1. And then I get 9x squared plus 5x. Subtract 1 both sides. I got 14 equal to 0. And then I think I'm going to think about the factoring, but it doesn't matter the factoring. We always try to get a is a positive. Okay, so I want to multiply by negative 1 both sides. And then I get positive 9x squared minus 5x minus 14 equal to 0, which is this is a factorable. So 9x minus 14 times x plus 1, which is x equal to 14 over 9 and x equal to negative 1. But your solutions are always an x and y order pair. So use each of the x to find the y, which is, I'm using this equation. So y equal to 5 minus of 3 times 14 over 9 squared, which is 5 minus 3 times of 14 squared is 196 over 81. And then 3 and 81 cancel. And then LCD is a 27 because 5 over 1. So multiply 27 both sides. I got 135, subtract 196 over 27. I got negative 61 over 27, and which is not reducible, okay? And then another x is a negative 1, plug it in. So y equal to 5 minus 3 of negative 1 square, which is y equal to 5 minus 3, which becomes 2. So order pairs are 14 and 9 with a negative 61 over 27. And the other one is x equal to 1 and y is a 2. So this you got the two solutions. Find the points where the line y equal to negative 3x intersects the circle x squared plus y squared. Okay, so we're looking for the one linear equation intersecting with a circle. All right, so this is good to use a substitution. So I want to plug it in negative x squared, so negative 3x squared plus, oh, what am I doing? I do the opposite way, sorry about that. And what I'm going to do is I'm going to plug it in this one into the y, isn't it? Okay, what am I talking about? Okay, sorry about that. So I got x squared plus negative 3x squared equal to 10. Now x squared plus 9x squared equal to 10. And x squared equal to 10 divided by 10 both sides is going to be 1. So x is a plus minus 1. So now you need to use x equal to 1 to plug it in this equation. So y equal to negative 3 times 1, which is negative 3. So you got 1 and negative 3. Now x is a negative 1. Plug it in negative 3 times negative 1, which is y equal to 3, which is a negative and 3. So there are 2 points. This the line and the circle gonna meet. All right, example 7. If the possibles of each system Okay, so this time equation 1 and equation 2. Okay, equation 2 is better to choose. I want to solve for y, which means you need to add the x and the x squared percent. Okay, so your y equals to x squared minus 1, and then you plug in this one into the y, which is 2x squared minus of x squared minus 1 equal to negative 1. So 2x squared minus x squared plus 1 minus 1. And then you got x squared equal to negative 2 if you subtract 1 both sides, right? But x equal to plus minus square root of negative 2, which is it's not a real number. So what do you say? This is the case of the no solution. So what is a no solution? It's going to be the inconsistent. Okay, for this one, okay, equation 1 and equation 2. So this time, I think the equation 2 has a fraction. So I want to solve for y. So 6x minus 4y equal to 3. So for y means subtract 6x both sides. I got negative 4y equal to negative 6x plus 3, and divide by negative 4. And then I get y equal to 3 over 2x minus 3 over 4. And then I'm going to plug this into the second equation in y. I got negative 3x plus 2 times of y, now 3 over 2x minus 3 over 4, which equal to negative 3 over 2. So negative 3x, and then if you multiply by 2 inside, I got positive 3x, and then it's going to be negative 3 over 2, which is negative 3 over 2. And then this 3x, negative 3x cancel. I got negative 3 over 2, same as negative 3 over 2, which means this is true. Means these two equations are exactly the same. So this is about identity. So the system is consistent, and then dependent case. Okay, so nice way to say is braces x and y, and then you got 6x minus 4y is always equal to 3. It doesn't matter of the x and y you choose as a solution. Okay. Alrighty, next problems. Okay, now I'm gonna use eliminations. Actually, the elimination is my favorite. Okay, so I hope that you like that too. So elimination means you just need to add it up, and then if there's a cancellation right away, that'll be great. If not, and then we need to make that happen for cancellation. Okay, so when you're adding it up, 2x minus 2x cancel, so you got y equal to 2 already. Goodness, isn't it short? And then let's find the x. You can use any equation, but I think I want to use equation 1 to choose. Okay, so equation 1, which is a 2x minus 3, but y is a 2 equal to negative 2. So 2x minus 6 equal to negative 2, x both sides. 2x equal to 4, so x is a 2, which is, it's going to be 2 and 2 as a solution. Alright, I want to do the addition method, which is, cancel 0, also cancel 0. So this is true, which means this is also the identity. So if that's identity, means the system is consistent. Also dependent. So you can use one of the equations, say 3x minus 2y equal to 1, okay? Alright, equation 1 and equation 2 this time. Elimination, cancel. Oh, but other side is equal to 4, which is a false. This is not true, right? So this is a contradiction, because 0 never becomes a 4. So this is contradiction, which is statement is already false. So the system is in. That means there is no solutions. Alright, next page. Now we want to solve the using the another elimination, but when you are adding it up, what happens is 5x minus 5y equals to -5, which is you didn't actually cancels out any of the equations. So this time we're gonna multiply in one of the equation or both of the equation and then make it as a nicely cancels out. So there's only the 2 and 3 as a coefficients, okay? So I want to match it to this two number as a 6 by multiplying. So in order to get a 6, okay, so either ones you can do that, but I want to actually cancel the y variable. So I'm going to multiply by 2, and then I'm going to multiply -3. Which is 2 times 2x minus 3y equals to 0 times 2. I got 4x minus 6y equal to 0. So I'm going to keep it here. So 4x minus 6y equal to 0. And then I'm going to multiply -3 for 3x minus 2y and equal to -5 times -3. So I got -9x plus 6y equal to 15. So -9x plus 6y equal to 15. Now adding it up. So -5x, y is a cancel, equal to 15, and divided by -5, so x is a -2. Now we just need to find the y. So in order to find the y, you can use either equation, but I want to use the equation 1. So 2 of the -3 minus 3y equal to 0. -6 minus 3y equal to 0. Add 6 both sides. -3y equal to 6, divided by -3, y equal to -2. So your solutions are -3 and -2. All right, the example B is the same way too, okay? So, but this time y variable has the different sign. So I want to match the 5 and 7 as a LCM, which is a 35. So I want to multiply 7 to the first equation and 5 to the second equation. So 7 times 3x minus 5 equal to 11 times 7. So 21x minus 35y equal to 77. And then equation 2, I'm going to multiply by 5, 4x plus 7y equal to 1 times 5. So 20x plus 35y equal to 5. So I'm going to put it together. So 20x plus 35y equal to 5. And then I'm adding it up. And then I got 41x, y cancel, equal to the 82. So divided by 41. Oh, we got the nice number, which is 2. Now I'm plugging in x equal to 2 of the one of the equation, but this time I'm going to do that in the second equation. So 4 times of 2 plus 7y equal to 1. 8 plus 7y equal to 1. Subtract 8 both sides. 7y equal to -7 divided by 7, -1. So you got 2 and -1. Okay, so this time you can use elimination 2. Okay, so equation 1 and equation 2, but equation 2 I'm going to multiply by -1. So when I multiply -1 x squared plus 2y equal to 6 times -1, I got -x squared minus 2y minus equal to -6, and then write down the first equation under, and then add them up. So x squared cancel, y squared minus 2y equal to 3. And then subtract 3 both sides. You got y squared minus 2y minus 3 equal to 0, which is a factorable. Y minus 3, y plus 1. So y equal to 3 and y equal to -1. And then plug in this y to the equation 2, right? So you got x squared plus 2 times of 3 equal to 6. So x squared plus 6 equal to 6. Subtract 6 both sides. X squared equal to 0, which is x is a 0. So there's a one solution. Now plug it in the second equation again with a -1y. So x squared plus 2 times -1 equal to 6. X squared minus 2 equal to 6 plus 2 both sides. X squared is 8, and then x equal to plus minus square root of 8, which is same as 2 root 3. So which is, one is a plus minus 2 root 2 with a -1 as a y. And the other one is x is a 0, y is a 3. So there are actually the 3 solutions, which means this circles and then parabola between the 3 different points. Okay, so now example 11. Linear systems occurs in the design of the roof trusses for the homes and the buildings. One of the simplest type of the roof trusses is the equilateral triangle. So if the truss in the figure has two 45-degree angles, and if the weight on the truss is 300 pounds, then the weight on each uh each after, so yeah, this is typos, okay, shouldn't be there, sorry about that. After is given by the system, so y1 minus y2 is equal to 0 because it's equilateral, so these two are the same. And then one of radical 2 times y1 and y2 equal to 300, okay. So find the weight of the after the symbolically, so this is just a typo, okay. All right, so far y1 and y2, okay. Oh, so sorry about that. So minus y2 equal to 0. And then, which is, I want to actually the multiply by, and the red 2 both sides to cancels out, okay. And then I get y1 plus y2 equal to 300 red 2. And now I want to add it up. So 2w1 equal to 300 red 2. So divide by 2 both sides. I got 150 of the red 2. So it is about 212.13. And then if you plug it in the w1 as a 212.13, so for w2 I got 212.13. Should be the same, right? They already said it. So that means the weight on each Raptor. Oh, sorry about that. I thought it was after. Raptor is about 212 pounds. All right. Next page, please. So example 12. The volume of the cylinder container with the radius r and the height h is computed by the V of hr equal to pi r square h. The letter surface area as of the container, excluding the circular top, and then the bottom is computed by the S of RH is a 2 pi RH. So they're only talking about the side. So write a system of the equation whose solution is dimensions for the cylinder with the volume of the 40 pi cubic inches and a letter surface area of the 60 pi square inches. Okay. So for the volume is pi r square h is the volumes of 40 pi. And then the letter area, which is going to be 2 pi r h, which is the same as 60 pi. All right, so that's the system. Okay, so let's solving this one. Okay, so, but in this time, there's a two variable r and h, right? And then what I want to do is I want to solve for h. So when you solve for h, you need to divide by pi r square both sides. So I got 40 pi over pi r square. And pi cancels out. I got 40 over r square. And then 2 pi rh equal to 60 pi. So for h, is h equal to 60 pi over divided by 2 pi r. And pi cancel. 2 goes 60, 30. Then I got 30 over r. Now, this is the same as h and equal to h, okay? So which means 40 over r square, I can say equal to 30 over r square. And then when you cross multiply, r square and then 30r. Sorry about that. And then if you do that is 30r square equal to the 40r. And subtract the 40r both sides. And then I got 30r squared minus 40r equal to 0. And the factor of the 10r as 3r minus 4 equal to 0. So 10r equal to 0. And 3r minus 4 equal to 0. So r is a 0, r is a 4/3. And then I cannot use the 0 for r. Yeah, because the 0 is a radius, cannot be the 0. And then solving for h, plug in one of the equation, but I'll use the second one. So 30 over 4 over 3. When you simplify, I got 90 over 4, which is a 45 over 2 inches. Okay, so radius is a 4/3 inches, and then the height is a 45 over 2 inches. Okay, all right, let's look at the last problem. All right, which is we have to talk about the joint variation. So same thing, yeah. When you have an equation have a more than one variable, so let m and n be real numbers, and the z varies only as the nth power of the x, which is k to the nth, and the nth power of the y if the non-zero real number k exists such that. So example 4. The strength of the rectangular beam varies only as the width and the square of its thickness. If a beam 5.5 inches wide and 2.5 inches thick supports 600 pounds, how much can a similar beam that is 4 inches wide and 1.5 inches thick support? All right, so I want to actually the define that S is the strength and W is the width and T is the thickness of the beam. So S equal to the K and W T squared. So S is a 600 and then K and W is 5.5 and T is a 2.5 square. And so for K will be 600 divided by 5.5 times 2.5 square. Of course, you can just simplify, but I just cannot keep it this way, okay? So now we are looking for the how much it can be similar being that is a 4 inches wide and a 1.5 inches thick supports, right? So I'm gonna plug it in. The K is 600 over 5.5 times 2.5 square, and then that's a K of the WT square, and then new W is gonna be 4, and then new T will be the 1.5. So plug it in. 600 over 5.5 times 2.5 square, and W is a 4, and then T is a 1.5 square, and then I got 157, which means that the beam can support about 157 pounds. Okay, so that's the last problem for 6.1. Thank you for listening.